I'm going to machine the back side of this this piece. We've gone through, we've set up our stock, we have our toolpath groups. Probably not going to go through and set up all of the operations, but we'll go through all of the preliminaries to get it to that point, and then you can take the operations from there. So the lesson really is managing the stock. We have the levels. The contain up here is not going to really help us. We need the surface. Curves not so much, and we need the envelope to pick our new starting point. The display of the stock probably not going to help here, so we'll go ahead and turn it back off so that I can just see the envelope. And what I want is to pick my next corner. All right, so we're looking at the reverse of this part. So I don't think it matters when I set up the plane, but let's go ahead and create a new machine group. Typically, machine groups would be between I want to run a mill or I want to run the lathe. The stock setup is predominantly the same here, but I want to manage it as a completely separate item with its own toolpath group. So when we right-click, go into the groups, I can select a new machine group, lathe, router, wire, but we're just basically going to reproduce the mill. All right, so it goes in, generates the same basic format. Not concerned with the files. We can go with program 2, assign, warn, and then the stock setup. We'll go with the corners, and I'll go from corner to corner. All right, so we still have our same basic dimensions. Let's see if we can center. And then always have to look around. I don't set these up that often. What I'm looking for is the plane manager. So we have the tool manager. Oh, should have looked at that. Didn't know there was going to be a quiz. All right, so we'll start back at the edit, view. Well, it's still not jumping out at me. Oh, I've switched into the solid modeling plane manager. So under the WCS plane manager will take us into this selection, and I want to leave enough room where I can pick. All right, so all of our standard planes show up: top, front, back, bottom, right, left, ISO. And we're going to go by geometry. All right, so one of the things with this plane manager, once I set this, if we were going to pick a different work offset, then I could go from -1 or 0 up to 1, or since I picked G58 out at the machine, then that would be G54 plus 4 gives me G58. So I would put in a 4 there. My geometry then, did we pick, well, we picked up the other stock. So pick an entity, pick the second line. We're going to translate through until we find one that looks pretty good. All right, so based on my orientation, so I'm picking up this origin and I'm placing it over on this corner. So this is probably one of the harder things to grasp for me anyway, was where I'm going to set up for that new plane. So, and the coordinate system around it. So part bottom, and then I want to make sure that my construction, my tool, the display, everything is set to that new part. So if we go equal, that'll also bring down the WCS. All right, so I'm not so concerned with the work offset. I just want to kind of point it out. And well, let's go ahead and set it. Set it as a 4. And our coordinate system, that all looks pretty good. -4, 4, 2, 1, 7 for the origin. Go ahead and accept. All right, so what that should do is get us to a point to where I can go ahead and set up for the containment area. So let's go back into the level, and since I'm accumulating, we'll go to 25 and just call this contain for the bottom, contain bot. All right. I'm going to select the top 4 of the envelope, and then do the Xform translate, and then this is going to be a copy. Let's see, we're going to, from this coordinate system, we're going to see what it gives us, but it should be a +1 inch. Right, so in relation to the new WCS, the new graphics view, even though the reference triad for kind of the global for the system is still showing Z down, we're now in reference to this new origin. Let's see what else. I would like to go with the new attributes. Pick up level 25, the color. See if we can find something. Oh, you're going to make me do all of them? Well, then that's not very efficient. We'll bypass that one. So okay, we got the copy in. Let's go ahead and accept it. We'll see if it left everything on level 25. So when I close off or shut off the envelope, and that's still in place, let's go ahead and clear the colors. So even though I didn't pick up the colors, we go up to Analyze in the Entity Properties. It did pick up the level, which is fine. And if I window pick around each of those, then for the wireframe color, right click, and we said we're going to go to brown. Don't know how visible that's going to be. Well, neither is the red for that matter. Oh, the surface got turned off. Okay, so let's check that real quick. I'll make sure that's highlighted. Right click. Picked up level 20. Okay, then it's defaulting somewhere. I'm not sure why it's defaulting. All right, so the first operation, and we'll just get this set up, and then you can go through the rest of the process, adding the finish, where to go, the contour and the parallel after the fact. So you're still going to generate the same 3. And again, if you want to experiment with the other items, I want to give you the base 3 that will make up the majority of the programs, and then as you need additional items, maybe the 1/2 inch tool couldn't get into a corner or something, you have to go to a smaller tool. Then that would be where we'd go over to rest mill so that it could take a 1/4 inch and go do a clean out. Flow lines are going to follow specific curves. Radial is kind of one of those. I have a hard time justifying radial because it comes back to center so many times that you end up touching the center, however many, but the outside may still have a pretty decent scallop. So, like I said, experiment with those and see if there's something in there that reside in a machine group, toolpath group. Okay, I didn't think I had one selected, but okay. Drive surface, enter on the keyboard. Alright, so I don't know what it barked at, but either that or it hadn't created the toolpath group yet. I have to go back and watch the video, see what I did. I'll pick up the containment, and we'll pick up the edge. All right, so the 1/2 inch, we're back to selecting the library tool. The library tools from previous, now it's not coming over, but we have the bull nose, and we had a 1/2 inch with no 0.62 radius. Well, and on the off chance that we're going to run this at some point, we'll stay with our feed rates. One of the questions determining the feed rates still comes back to we're taking our best guess. It is on this machine, light duty machine, I don't want to push it too hard. On the roughing passes for the other piece, we were able to double that, go up to 32 inches a minute until the very last passes. And when it got to the last passes and the helical entry or the starting off of the part was not able to be calculated, then it went over to plunge, and then I really wanted it to plunge at 8, not at 16 or 32. So in this case, we're not running production on this. You know, we're going to make one mold or we're going to make one set of molds, but this is not a high production piece. If it were, then we would refine it and go through the steps as we got it out to the machine, saw how it was going to perform. All right, so you know, it's better to be on the low side and run the overrides at the control. Come up with some reasonable numbers for the material. Aluminum, sure, if I had a 12,000 RPM spindle, I would probably still be running the 1/2 inch tool somewhere around 8,000 or 9,000 RPM, but my feed rate would be comparably faster, up around 60 to 80, maybe 90 inches a minute, depending on how aggressive, how much cut it was going to have to take, and what I was looking at as depth of cut. All right, so we just react to, I like to say observe and react. Get it running, and then as you observe and react to the tool conditions, the rigidity of the setup, everything else, there are things that are going to jump out at you and say, yeah, I can go a little faster, or no, that wasn't really a good guess, I can pull back some. 1/4 inch retract, feed plane, 100 thousandths incremental worked pretty good. We're going to stay with the 30 thousandths on the surface. And then the rough parameters, max step down of 100 thousandths. That worked out pretty good because in the calculation is it pulled, well, at least on the other piece, it pulled back to about 80 thousandths. So based on 80 thousandths working pretty good, if it did take 100 thousand step down, it wouldn't be that big of a deal. All right, so let's go with a maximum radius of 0.25. We'll close that up a little bit. 0.1. Clearances to the walls, plunge angle of 3. And then this is where if the entry attempts fail, plunge or skip. Well, I'm not sure what it's going to skip to. I don't want to skip the rest of the geometry and not complete the rough. So as long as I'm plunging slow enough or plunging at a reasonable feed rate, then I should be able to manage a linear, vertical linear move into the part. And then the entry picks up the plunge rate. Okay, so go ahead and accept that one. Pocket parameters. I still like the high speed. We determined that the trochoidal, but that little bit of transition, that little gentler transition, did not load every time it stepped over to a new level. So when we look at the high speed, this little bit of arc going into the next 45-degree angle makes it just gentle enough to not see heavy spikes in load from one pass to the next. And then the finish pass, one finish pass with a spacing of 10 thousandths, that's what it's going to leave, and then come around. I don't know if it was a calculation on the 100 thousandths, but on the roughing pass for the other side, is it stepped, and then it came back and stepped again, and actually did 2 finish passes. So I don't know if that had to do with the thin wall. So what is the explanation? Z finish per rough depth cut. Well, that would be why it took 2 finish passes for, so one that I missed. You know, I observed something out at the machine, I have the question, We don't need a thin wall check, so that should only go around once to clean up. And then we'll go ahead and accept. Searching for helix center. I don't know if I should be, oh, there we go. All right, so same thing is we're going to have those issues in the corners, and because of all of these corners, it's going to be a little more pronounced. All right, so one thing that I would want to check is that we are inside to outside. It can plunge outside. That worked out pretty good. On the containment, we didn't tell it, okay, on tool containment, keep everything inside, or to the, let's see what it does with the outside. Now, additional offset would mean that it could find potentially a way to get further deeper than what I really want to go. So we're going to bypass the additional offset initially and see if that works out for a starter. And we'll give it a second. So even though we went a little, doesn't look like it went too much deeper, but being able to start to the outside, especially in this case, it doesn't look like I'm going to end up with a plunge, and it's going to clean up the corners where previously we stayed inside. It stopped about, I don't know, third of the way, 2/3 of the way down because it couldn't calculate past that edge. All right, so on the waterfall, as long as I'm not getting past the stock or seeing anything too crazy, then we'll run with it. All right, so your task is to set up this second machine group with its WCS, get everything aligned to it, and then work offset 4, part bottom, whatever you want to call it. Again, make the names, make the choices based on things that make sense to you, that you're going to recognize and be able to come back and use consistently. And then go ahead and add the other 2 operations for the contour and the parallel.